going to be a recorded one today because we're testing things. We're having fun with this test. So everyone's got their paper? We're all on question 1? Okay, so first thing we want, well, I got to get my drawing tool up. We're going to go with blue today. Is this visible enough for you guys? Yeah. Okay, good. Shoot. Okay, so because we're doing this as orders of operations, the first thing we got to start with is parentheses. There's one set of parentheses here, but there's a second set inside of that. So we're going to start there first, all right? Inside of that set of parentheses, we've got 5 times 2 minus 8. Now, at that point, we're going to look at the lower levels of PEMDAS to see what we're going to do first. In this situation, we're going down, we're going to go, is there any exponents? No. Is there any multiplication division? Yes. So we're going to do multiplication division before any addition subtraction. When we do that, 5 times 2 is 10. Okay, cool. 10 minus 8, 2. Okay, so we got a 2 inside of that little branch there. And what's on the outside? We got 3 plus 3, and then we've got our big parentheses, and then that 2 on the outside. So again, we're going to look inside of our larger parentheses here, and we're going to see addition, and we're going to see multiplication. Which one do we do first? Multiplication, all right. So it's going to be 3 and 2. It's going to be 6 plus 3. That's inside the parentheses, so we're going to do that first before we even deal with the 2. 3 plus 6 is 9? Okay. I'm losing voices. Come on, guys. So 9 times 2 is going to be 18. I'm going to go through these few first ones really quick because we want to have more time for the later ones, right? Because those are the scary ones. All right, so multiplication. When we do multiplication, we've got more than one digit in each one. Hello. Hi. Did you sign in over there and get your paper and start with us? We're already on number 2, though. Just letting you know. Sorry. We got 98, and we're going to write it on top of 88. And we're going to do this as individual numbers. So in the first set, we're going to do 8 times 8, which is, anybody? Uh-oh, I lost them already. 64, okay, cool. So we're going to put a 4 here, and we're going to put a 6 up here as a reminder. Now 8 times 9 is going to be 72. All right, 72 plus 6 is 78. So I'm going to put a 78 down here. Now on the next one, I'm going to put a 0 because we're skipping a place because it's 80 instead of 8. And we're going to write the same numbers because it's the same multiplication. 4, 8, 7. And I can do that because that was 8 and that was 80. Now doing this, we're going to add these together. We're going to add 4 to a 0. 8 and 4 is 12. We're going to carry the 1 up here. 7 and 8 is going to be, anybody? Well, let's just put the 1 in there. 8 plus 8 is 16, right? So we're going to put a 6 down there. We're going to put a 1 up here. 7 and 1 is going to be 8. So we're going to have 8,624. We good? All right. Let's get question 3 down. All right, rules of operation. What was the first thing we looked for? Parentheses. So I've got 1 pair. I've got 2 pair. I've got, well, that's just saying I've got a negative number. So that's not really a parenthesis. We're going to ignore that. So going from here, which one am I going to do first? There we go, left to right. So we're going to start with the first one. Minus 5 plus 11. That's going to give me a positive 6, negative 6? Positive 6. Okay, so we got a positive 6 here. And then for the next one, we're going to 14 plus negative 7. So we got 14 good guys, 7 bad guys. How many are we going to have left? 7 good guys. All right, so we're going to have a positive 7 there. And then we've got the negative 15, right? Or, well, plus the negative 15. At this point, we're going to go from left to right order because it's all addition and subtraction, right? 6 plus 7? Anybody? 13. 13. Okay, 13. And we're just going to say minus 15 because it's, you know, adding a negative number. So 13 minus 15 is? Negative 2. Is my group falling asleep again? Come on, guys. All right, this one's got exponents in it, but we still got to start with what? Parentheses. There we go. So we got 1 pair of parentheses. Do we have another pair inside of it? Yes, we do. So we're going to start there. What can we do in that pair? Well, the exponent's on the outside of it, so we're going to leave that till after we're done with the inside because parentheses come first. So inside that parentheses, we got addition, subtraction. So we're going to add a negative 2 to 3, which is a 1. So it's going to be a 1 squared times negative 3 and 4, and then there's a negative on the outside of that. So when I do this, am I going to multiply the 3 first, or am I going to square it first? Square it because it's an exponent. 1 times 1 is still 1, so it's just going to say 1. Stop it. All right, so then 1 times a negative 3 is going to be, I could write that better, but oh well. It's going to be negative 3, right? So stop it. Negative 3, I got 4 inside the parentheses. What am I going to do? You stop. Hello? There we go. Okay. We're having some technical difficulties. 4 minus 3 is going to be 1, right? And because we have on the outside of the parentheses a negative, it's going to end up being negative 1. Right? Okay. Any holdups, any questions? Are we doing good still? No? Okay. Now we're going to come with fractions. Subtract and state your answer in reduced terms. So we need to get them into like terms first, right? What's an easy way to get them into like terms?
Find a common denominator.
Common denominator. What's the common denominator between 15 and 6?
50.
That would be a common factor.
Do you have to look for the LCD?
Yep. Least common denominator. How are we going to do that?
Find them.
Find them? Okay. Good job. We're going to do 3 and 5. That's primed. Okay, 6 is going to be 3 and 2. So how am I going to find their prime factorization? Multiply the ones together that they don't have in common. So 1, 3, 1, 5, and 1, 2. We're not going to use that 3 because this one already has a 3, okay? So if we do 3 times 5 times 2, we're going to get 10 times 3, which equals 30, right? So at this point, we're going to take the 30. How are we going to get 15 to 30? Multiply it by 2. Yep. So that means this whole equation, 4 over 15, is going to be multiplied by 2. And what are we going to do with the 6? How are we going to get there? Right, we're going to multiply that one times 5. So we're going to multiply 5 over 6 times, come on. I'm going to take a pause moment. Okay, where did my thing go? I want my other book back. All right, give me a moment. Hey, there we go. Oh, I didn't record that part. So this was by 2. And the other one's going to be 5 over 6. And we're going to multiply that by 5, right? Yep, okay. So we multiply fractions, we've got to multiply both the top and the bottom. So it's going to end up being 8 over 30 minus 25 over 30. First of all, it's going to be a negative number, but how are we going to figure that out? It's going to subtract the top parts across, right? So go from 25 and then go 24, 23, 22, 21, 20. So it's going to be 18, right, over 30? Negative 18 over 30, does that sound right? Because we went negative 25 and we added 8 to it. Can I simplify that?
9 over 10.
9 over 10? All right. Are you sure it's going to be 9 over 10? How about 9 over, or 6 over 9? Or 6 over 10? 6 over 10?
6 over 10.
6 over 10. Can we simplify that again, anybody? Can 6 over 10 be simplified? 3 over 5. Okay, thank you. 3 over 5. I like that. That's got prime numbers. We're going to leave that alone because it's got prime numbers, okay? We're on questions. Oh, good point. Yes, it is, because we almost forgot our negative on there, didn't we? Because it was negative 16. It's going to be a negative 3 over 5. I've got enough monster in my system. I'm probably not going to be able to keep up with myself sometimes. See, we all make mistakes. So, that doesn't look good.
So you want to convert both the decimals into fractions with the same denominator? I mean, both fractions.
Both fractions you want to put into the same denominator so you can then transfer in addition and subtraction. So we're going to do the same thing with this one, but they're all either over a 7 or a 2. So we're going to make them all over a 14. And since everything's divided by 14, we won't need anything to be divided by 14, okay? So we're just going to eliminate the 14, okay?
Right. That's the LCM or the LCD?
It's the least common denominator. It's called LCM, the least common multiple as well. So, yep. So when I do that, that means that my 5 over 7 is going to be multiplied by 2. My 1 over 2 is going to be multiplied by 7. My 5 over 7 again is going to be multiplied by 2. And then my 1 over 2 is going to be multiplied by 7. This is a subtraction, that's addition. So doing this, we're going to get 10 over 14 plus 7 over 14 over 10 over 14 minus 7 over 14. This still looks very messy, but at this point, I can cross out all of the 14s because everything's divisible by the same thing, right? So now I'm going to go 10 plus 7 over 10 minus 7. And what's that going to give me?
17 over
17 over 3. Wasn't that hard, what? So whenever you see the same repeating denominators, do your best to get them all to one number so you can cancel them all out. I promise you guys will be able to get to this later on the email. We're putting this up on an email. I don't know the full things and how we're sending it out, but when Adam shows up, I'll be able to get that question answered. But we are recording this. That's why we're recording a session. That's why I've got a lavalier mic on, so you guys can hear the session over again if you missed anything. I've got 30 questions and I've got 2 hours. I'm trying to do my best here because I want to get to those big questions at the end so you guys are doing good. Multiplication with decimals. I'm going to treat this like regular multiplication. And then it was 3, 3, 2. And yes, the decimal is here, but we're going to ignore them right now. We're going to actually say 1, 2, 3, 4. So I moved 4 to the right. I moved 4 decimal places to the right just to make them whole numbers, okay? So I'm going to go 2 times 6 is 12. I'll put 2 there, put 1 up here. 2 times 9 is 18, add 1, so it's going to be 19. Add that down there, put the 1 up there. 2 times that is 0, but there's a 1 there carried, and that's 2. That's going to be our first number. Put a 0 there, 3. So 3 times 6 is going to be 18. Put an 8 down, carry a 1 for that one. 3 times 9 is going to be, anybody? 27 plus 1, so it's going to be 28, right? Carry a 2 there. 3 times 0 is 0, but we got a 2 carried, so we're going to bring down the 2. And 3 times 1 is 3. The next line, we got to do a third line because we got a third number. But with this one, it's the same as the last number, right? So I'm just going to repeat out the same number. 8, 8, 2, 3. Now I got to add them all together. We're going to put down our 2. 8 and 9 is 17. We're going to put down our 7, carry the 1. We're going to put 8 and 8 together is going to be 16, 17, 18. So we're going to put an 8 down, carry the 1. 2, 4, 4 plus 8, so it's going to be 10, 12, 13. So we're going to put a 3 down, carry a 1. That's 5, 6, and then we have a 3. Now, remember how I did 4 to the right up there? I now have to go 1, 2, 3, 4 to the left. Now I have 36.3872. Hopefully they want me around. But that's how you would get that number. What's up?
I actually got this one wrong because I thought that I assumed that when you get to the last 3 that you multiply 10.965, that you only add 1 0 at the beginning.
Because remember, that's at 300, so there's 2 zeros behind it. So imagine all these places become zeros down there. All right? So if you're here in the first level, you immediately multiply there. When you're in the second level, you multiply 1 out because it's a 10.
Okay.
When you're third level out, you multiply 3. So it moves over in this. See how the grid system kind of helps you? I could have written it a little bit better in the grids, but I tried to at the end.
Okay, so when it's 3 digits multiplied by, you add 2 zeros to the back.
Right, right. So if it's going to be by 4 digits, what's it going to be?
5 or 4 zeros.
It's 3 zeros because it's 4 digits. Because 1's the number and then the 3 are zeros.
Okay.
And that's how you treat them so that you can add them all together in the end, okay? All right, cool. We've got that. Everyone else got that question? Evaluate. So first of all, we're going to have to do some decimal addition, and then we're going to have to do some subtraction. So if we've got 4.3 and we've got 7.36. Now here you want your decimals to line up, because if you don't line them up, you might put numbers in the wrong slots. So if I add the 3, it's going to be added to a 0. Put the 3 down. 7 and 3 is going to be put together. It's going to make a 10. So we're going to put a 0. Carry the 1. 6 and 4 is, yep, but we got 1 there, so we're going to make an 11. 11.03 is being subtracted from 11. It's going to give us equal to negative 0.3. Looks scary, but when you line it up, it's not so hard, okay? Just got to remember, you're lining up. When you're addition, subtraction, you line them up. When they're multiplication, division, it doesn't matter where you line them up as long as you count how many decimals you moved.
Now, I have a question.
Yep.
Why wouldn't it just be 11 minus 1103? Like you just taking away 11 and then you would do 0.3 positive.
Why is it not positive? Because the 11.03 is the negative one, and the 11 is the positive one.
Okay.
So that means we dropped more than we brought up, okay?
I was confused about that because I actually thought it was positive 0.03. Because I was like, we just take
Right. But when I did this, when I did this, there's a negative sign in front of it, and we treat that negative sign as going on top of that number when I'm done within the parentheses.
So it's the priority.
Right. It's the priority. It's as soon as I wrote this number, I plugged it back in up here as 11.03, and it just happened to have a subtraction sign in front of it. It didn't have any say in the matter of being negative or positive.
Right.
Now, if it was negative itself and that happened, I would then automatically turn it positive.
Right.
Okay?
Okay. I got it.
All right.
So if the subtraction sign wasn't there, you would multiply, right?
Yes. Because the two numbers, if the number is up against a parenthesis, you're multiplying it. It's shorthand. Like this 3 here. This 3 is going to get multiplied across. So because we're doing that right now, we're going to do a distributive property, which means I'm going to take the 3, I'm going to multiply it by the first and the second number. Same thing with the 10 on the 6 and the 2. So 3 times 6 is 18. So I'm going to start with an 18W plus 3 times 2 is 6. All right. So we're going to start with that part. Then since it's keeping positive, it's going to be positive 10 times positive 6, and that's 60. So it's going to be 60W, because there's a W there still. And it's going to be 10 times 2, which is going to be 20, right? Now I get to add like terms, because these have W's. They speak the same language, and because these are numbers, they speak the same language. So we're going to have a 26 over here, and we're going to have 18 plus 60, so that's going to be 78W. That's as far as we can go right now. It's not equal to anything. We don't know what it's going to go, so that's what we got. All right? Number 10, use the distributive property to simplify the expression. So we're doing this and we're multiplying by a fraction.
So you want to convert the first and second number into parentheses to fractions, or put them over 1.
You can do that. There's another way of doing this, and this is just because. Okay. So she's got to hold on. All right. So for this one, instead, imagine it like I said, 5 times this 12x minus 30 divided by 6. You see that? It's the same fraction. It's just written out in math. So that means if I multiply 30 by 5 and 12 by 5, and then I divide them all by 6 at the end, I'm going to get the same number as doing that whole fraction multiplication. I don't like doing fractions. I'm a math person. So I find ways to do them numerically. So 5 times 12 is, anybody? 60. I like that. 60. Good. Got a good, quick, even number. 60x minus 30. So 5 times 30 is going to be 5 times 3. Anybody? 5 times 3 is 15. So we're going to add a 0 because it's on the end. So that's going to be minus 150. Now we got to divide this by 6. 60 divided by 6 is just going to give me 10, right? So we got a 10x minus 150 by 6. Can I do that? How do we want to do that? Let's just do long division real quick. 6 on the side. 1, 5, 0. Can it go into 1? No. Can it go into 15? How many times can it go into 15? 2. So we're going to put the 2 up here. We're going to put the 12 down here. 15 minus 12 is 3. I know, I'm going fast. That put us to 30. So now we're going to do, how many times can I get 6 to go into 30? 5. And that'll be perfect, so that'll cancel out with no remainder. I now know that 25 is the number that I'm going to put over here. You don't have to learn all the weird stuff with fractions if you know your long division and multiplication good. If you practice it often, you could run through a number like that and find the answer very quickly. Okay? We all good? I'm getting some people going, what? What did we do? Okay. We just multiplied it, and then we divided it, okay? It's not a fraction. It's not a fraction. Don't call it a fraction. It's just like saying accounting. If you say accounting, all of a sudden everyone gets scared. If you say math, oh, okay, it's not as bad. All right, so we're going to question 10 or 11. Solve for W given this equation. So I don't have any numbers, which means that it's going to be in terms of L and P, right? So whenever we're trying to figure out an item, which is like W, a variable, we do reverse PEMDAS. It's weird, but we do subtraction, addition as a set. Then we do division and multiplication as a set. And then we deal with, you know, you guys call them exponents. I used to call them powers. And then parentheses as a group, okay? So we're doing it in reverse. So if I want to get this W alone, this is the guy I want to get alone. What's the first thing I'm going to do on that side of the equation? I'm going to subtract. What am I going to subtract? Let's subtract 2L because W is on that side of the equation. I want to get everything away from him, right? I want him to be alone. So let's subtract 2L from both sides. And that's going to give me P minus 2L equals 2W. So I did my subtraction and subtraction. Check. What's my next step? Division, multiplication, right? Yep. So we're going to do that real quick, and I'm going to divide W by 2 because I want to get him alone, right? So that means that P minus 2L over 2 equals W. We've solved for W. Whenever you're trying to solve for X or solve for Y in geometry, you want to use reverse PEMDAS because it allows you to pull things away from it. When you're solving it, you start with PEMDAS and you work your way down. But when you're trying to solve for an item, you just pull everything out in the reverse order. And if there was then suddenly like a power on there, then I'd have to square root this whole thing, and that's just another mess. They're not going to do that to you, I promise. I've never seen a test do that on a 1022 course. But let's look. Let's see. Number 12. Solve for X. Okay, so in this scenario, we're going to get all the X's on one side of the equation, and we're going to get everything else on the other side of the equation, all right? We've got X's on both sides. So first of all, we're going to have to distribute. If I distribute, it's going to be 7 times x is 7x. 7 times 5 is 35 plus 3 equals negative 9 times x, negative 9x. Negative 9 times negative 8, positive 72. Good job. And then we're going to have the minus 3 there. All right, so let's just group like terms on each side because we have numbers that are on each side. Let's just pull them together real quick. So 35 plus 6 or plus 3 is going to be 38 plus 7x equals negative 9x plus, we're going to take 3 out of it, so it's going to be 69. All right, so because I don't like dealing with negative x's because it means you have to divide the whole thing by a negative number, we're going to move all the x's in whichever direction is going to make it positive. So if I add 9x to both sides, it would make this side positive. But if I subtracted 7x from both sides, I'd end up with a negative number. So it's better if I add this 9x to both sides. That way I don't have the trouble later of doing the whole flip everybody's signs, and it's not fun. So 7 plus 9 is 16x plus 38 equals 69. Now I'm going to have to do some subtraction, right? Can I? There we go. Yep, so we're going to subtract 38 from both sides. Let's do that math real quick. 9 minus 8 is going to give me 1. 6 minus 3 is going to give me 3. So 31, right? Positive 31. So 16x equals 31. So we did the addition, subtraction. What's up?
Isolate the variable by dividing both sides by 16.
What? Yep.
Isolate the variable by
What?
dividing both sides by 16.
Yep. That's what we're going to do. And it's not going to be pretty. It's just going to, is there anything we can figure out how it's divisible?
They're both, I don't know if they both can.
Let's just go up our prime numbers, because if we can do prime division, it works better. Are they both divisible by 2?
No.
No. Are they both divisible by 3?
No.
This one's 31, so we know that's not true. Are they both divisible by 5?
No.
How about 7?
No.
No. Okay. 13?
Maybe.
At this point, well, 16. You can't. You've already gone over half of one of their sizes, so you know that none of them are factor stuff. So it's the prime answer or the reduced form. Right. So it's going to be x equals 31 over 16. And you do that just by going after your prime numbers, because if you can go after your prime numbers, you'll usually find more prime numbers to pull out of it until it's at that reduced form.
How do we know, where do we get the denominator from?
The 16? Because we are multiplying 16x to get 31. Like, remember over here when we did 16x. What are you doing? 16x equals 31 because we did the math. But we want to get x alone. So the next thing we do is we multiply or divide. So we divided both sides by 16. When we did that, the 16s here canceled out, and we ended up with 16 under 31, which gave us that fraction. This is why I don't like calling them fractions, because suddenly they just appear, and they're scary. Okay?
And then if I did a check, you plug back in
Yep.
31 over 16 into the answer?
Yep. Though in that case, I'd want a calculator, because...
Yeah, I would do. But just to make sure that each
Yes,
side,
that would be your way of checking it. I wouldn't fully go on checking this one because this would probably be a small point value question, and there are other bigger questions that you could check a lot simpler, and it's better to get the points that you know you can get. Like, from test taking experiences, I go for all the questions I know straight off the bat, and then I go after the hard ones that I know I can check. Okay, any other questions right now? Hi. We good? All right. Next question, number 13. Ugh. Well, now we're going to do division with decimals. So remember how we did the multiplication? We moved all of the decimals out. We're going to do the same thing here. So this is actually going to be a 2,146 divided by 37. Now, I moved out 1, 2, 3, right? So I did 3 right decimals. Can 37 go into 2? No. Can it go into 21? No. 214. We know it can go into 214. Now we have to play a guessing game. How many times can it go into 214? Anybody got we got to see how many times 37 can go into 214.
5.
5? Want to start with 5? Okay. So let's do the multiplication of that real quick. 5 times 7? 35. So we're going to put a 5 down here, put a 3 up here. 5 times 3? 15 plus 3, so that's 185. Can I put another 37 in there before I go to 14? I can't? You sure?
Yeah, sure you can.
I can. So let's go with 37 times 6. 7 times 6 is 42. So we're going to put 2 down there, put the 4 up there. We're going to do 6 times 3 is 18. So 18 plus 4 is going to be 22. So it's going to be 2, 2, 2. Okay, so it's too big. You got it right the first time. Well, that's how we test it. So we got a 5 here. We're going to put this 1, 8, 5 down here. We're going to do our 14 minus 5 is going to give me, what happened to all my people? 9. Okay. Come on, guys. Do we need to go get a coffee break? All right, so we have to borrow 1 over here. It's going to be a 10, so it's going to give me 2. So it's going to be 29, and then we'll bring down a 6. So we know that 222 is 6 times 37. So we know that it'll at least fit in 6 times. Let's go 7 times. So it's 37 times 7. I'm having a really bad time writing my lines right now. 37 times 7 is going to be, right, so we're going to put the 9 down, carry the 4. We're going to put 7 times 3, 21. Yep, 25. Can we put in another 37? Are you sure? Okay, well, let's try. It's not that hard to try now, is it? All right, so 8 times 7. 56. All right, cool. 6. Put a 5 up here. 8 times 3? 24 plus 5? Hey, look at that.
Would it be easier just to add the 37 to the 259 and C and then just
Yeah, you could do that. But you start getting those feelings from here when you realize which ones are going to cancel out. 2, 9, 6 cancels out. So we know that it's 58, right? Right, we got to now move back our decimals, right? So if I move back 1, 2, 3, should be 3 times. Let me check that real quick. I think I might have moved it the wrong way. Yeah. Do what?
We got 29 over 5 before dividing 1,073 over 185 by 37. So basically we got P equals 1,073 over 185.
Okay.
And then we divided that by 37 and simplified it to 29 over 5. But we did a different method.
Okay.
We just we had 3.7
Yeah.
P equals 2,146, and we just put them. We divided them both by 3.7.
Right.
Okay.
And canceled out 3.7, so we got P, and then had to divide,
Right.
124. Well, 2,146 by 37.
Yeah, which is what I got there. I'm just trying to figure out how far to move back to decimals, because we know that it went in 5, we know it went into 8. I'm just trying to figure out where I put it back to decimals, and I'm having a problem.
3 up there?
What?
Did you say you went 3 right?
Yeah. So that's why I was going 3 back, and then I'm going, does that make sense? Because even if I test that I don't think that works. What? Why? Well, I've got 3 that I had to move out, so I got to move 3 in.
So the X will be zeros, right?
Right.
So it's 0.0058.
Right, but that doesn't add up to that, because if you did a test on it, I need it to be at least something times almost 7, so it should be a 5. No. Right. 5.8 times 37. 8 and 7 is going to be 56. Put 6 there, put the 5 up there. It's going to be 3. I'm going to carry the 0, 3.
7 and 5 is 35 plus the 5, you got 40, not 35.
40, my bad. See, this is, I'm still waking up today, I guess. 3 times 8 is going to be, what? 24? Okay. And then 3 times 5 is 15, plus 2 is 17. 7 plus 4, 21. Yep, that's it. Okay, why they? Okay, now I know why I got that wrong. Because I'm doing division, not multiplication. When you're doing multiplication, you go the same direction with all of the dots. But when you're coming back, I'm dividing 2 dots from 1 dot. So basically, I get to say 2 minus 1 equals 1. So I only moved 1 back over. And that's why I only moved 1. You were right. I just couldn't figure out why. I forgot my rules. It's been a semester since I've done this. I'm sorry. But yes, 5.8 is the right one. And you can look at that by going 5 times 3 is 15, and then looking at the decimals and saying it should get up to 21. That makes sense. But going and saying 0.05 times 3 is 21 doesn't make sense. Right. Right. Solve for x given, okay, so
You have to subtract.
yep.
If you have 3, and on the other side you have 2, it's 3 minus 2.
Okay, so are we all good right now? Yeah. All right, so for this next one, 14. I know we hate fractions, right?
Yeah.
I'm going to get rid of them again.
Good, come on.
Okay, so cool. So the whole goal is to get both fractions out of here. And since we got one that's a fifth and one's the third, what's going to be the common denominator between those two? 15. Okay, I like that. So what would I have to multiply 1/5 by to get 15? Have to get 3? Okay. And I'd have to multiply 1/3 by what? 5. Okay. And, well, I've got a negative 1 over 1 over here. So what do I got to multiply that by to get 15?
15.
Okay. I know, I'm still doing fractions. They're still there. Give it a moment. So 3 times the 1 is 3 over 15, right? X plus 1 times 5 is going to be 5 over 15 equals negative 15 over 15, right? So everybody's divided by 15. Remember what I did earlier? Everyone was divided by 14. I just got rid of all the 14s. I just did that again. So that means now I've got 3x plus 5 equals negative 15. Does that look a lot easier? Fractions went away. They're gone. We don't like fractions. They're gone. We just said since everything's divided by the same fraction, we don't need to care for it because it's on both sides of the equation. So now we're going to subtract our 5 from both sides. That's going to give us our negative 20 equals 3x. And then what are we going to do?
Divided by 3.
Divide by 3. I like that. Can I divide 20 by 3? How? 20. Almost made me write negative 30 there. Because they don't share any prime factorizations, there's no way I can divide them by each other, so they're stuck in that form. Negative 20 over 3 equals x.
Why do you subtract 5?
Why did I subtract 5? Because I'm trying to get x alone. I was solving for x.
And can we simply do it by switching, because I don't do that stuff, so when you have, I simply just, if you have a positive, you just take it to the other side and make it a negative.
That's basically what I'm doing, yes. I just write it down there just so I keep track of it that I subtracted it from both sides because I'm trying to keep the scales the same. And if I'm going to take 5 away on this side, I'm going to take 5 away on that side.
If the 3x is on the other side,
yeah.
So we're gonna move 15, right?
Yep, we'd move 15 away and then we divide by 3 again.
So you always divide by
Yep.
That is connected with the X.
Right. If it's connected with a number, it's multiplying there. There's that little invisible dot or parenthesis. So that means you're going to divide to cancel them out. Okay? But that's just, fun thing that math doesn't want to tell you is when we put two numbers together, it means multiply now. Surprise. We good? We good with this one? All right. Let's see what other mess things we got. Question 15. Inequalities. Okay. We're going to imagine it's an equal sign for almost the entire one, all right? I'm not even going to write the sign. I'm just going to make this line down here, okay? So at this point, we're going to look at it and go, which one has the bigger x value? Which one's going to give me a positive x value? If I add, okay, so if I add 9x to both sides, so I'm going to do that 9x to both sides. And that, so when we do that, we're going to end up with a, anybody? 2x plus 2 something negative 10. All right, now what am I going to do?
Subtract 2 from both sides.
Subtract 2 from both sides. That's going to give me 2x something negative 12. I like it. All right, and then what must I do? Since we're doing this reverse, we did our addition subtractions, and we now need to do our multiplications divisions. So we're going to divide both sides by 2, and that's going to give me x something negative 6. Now, I didn't deal with it the entire time, right? The centerpiece. Did I ever divide by a negative number? Then the sign is going to remain the same. As soon as down this line I see something that divides by a negative number, I put a cross on this little line I've made, because that'll.
You can move also just turn it the opposite way. If it was a greater than equal than less than, like if it was a less than equal to or greater than equal to sign, if you had to divide or multiply each side by a negative number, you would just flip it the other way.
Right. But some people get confused by that, so I'm just making a line. And the moment that I do that negative multiplication or division, I put an X on that line, and then I'll go back and say 1, 2, there's 3 of them, so the sign flipped 3 times, I'm good. I know which direction it's going. Because I'll go, it's here, it went that way, it went this way, it went. So it's easier for me to track where it flipped and when it flipped. And I don't have to worry about making sure it's always the right one. So at this point I go, nothing happened, we're going to keep the same sign, negative 6x, okay? See? Not too bad, right?
So for the 2.
Yes?
After we move we always have to look for the big number, negative 9.
Well, it's not the big number, it's what's going to get me a positive number. If I put positive 7 over on that side, it would have been a negative 2. And then I would have had to flip the sign. I don't want to flip signs. I don't like flipping negative x's or dividing by negative numbers that are multiplied to an x. So I just move it to a positive x side. Because one side is going to be positive and one side is going to be negative depending on how you move it.
And so after you were done, then you get it. After you had the positive number, which is 2x.
Right.
Now you have to move the 2 also to both sides.
So what I did first is we moved all the x's over. Right? We added 9x to this side. So that gave me 2x plus 2 equals negative 10.
It's combining like terms.
Right, but I want those numbers to go away from the x because I'm solving for it. So then I go and do the reverse PEMDAS and I say I'm going to subtract out 2 from that side. So I subtracted 2 from both sides and that gave me the negative 12 and the 2x. At that point, I'm going to get rid of this 2 by dividing it by 2. So that makes this just become x. And then this side ends up being divided by 2, and it gave me the negative 6. Are we good? We understand how inequalities aren't that dangerous, right? Just ignore it as long as you can. All right, so that was number 15. Number 16. We're actually a little bit ahead of schedule, which means I get to slow down for the really tough ones and answer questions. All right, choose the graph that represents the solution. First of all, we got to make that look prettier. And it doesn't look nice. So remember how I drew my lines? I draw my lines again. All right, so the first thing I'm going to do is because all the x's are on one side, I'm going to start moving stuff away from it. There's a -1 there, so I'm going to add 1 to both sides, right? If I add 1 to both sides, those 1's cancel out, and then I get a -12 equals -3x, right? So at that point, I'm going to divide both sides by -3. Oh, -3, right? I divided or multiplied by a negative number, right? So that happened. So then we're going to have x. And what's -12 divided by -3? 4. It's got to be +4, right? What's my sign going to do? It flips once. So it went from being greater than or equal to less than or equal to. So we're going to say x is less than or equal to 4. It flipped because we divided or multiplied by a negative number. Because when you're multiplying or dividing by a negative number, it sends it the other direction on the, that's the best way I have to explain it. It's some weird math thing. Yep. So we look at them and we go, okay, well, 2 of them are going to negative infinity, right? 2 of them are going to positive infinity. Positive elimination, we know that these 2 aren't right because they're going to positive infinity and we're going to negative infinity, correct? And then at that point I go, what sign do I have there? I have an equal to, an equal to. Equal to's are open dots or closed dots, people? Closed dots. Okay, so that means, yep, the last one's right. This one cannot be it. Does anybody have a problem remembering when we use open dots, closed dots, equal thens, or set notations? Does anybody have that problem? Okay, so we've got a few of those problems. So I'm going to run over here and do something real quick on the side. Oh, no, don't do that. My hand should be the same as the pen. That's why I'm confused. What did I do? Go away. There we go. Okay. Come on. Yeah, I guess I need to take off my jacket. So, all right, I'll take off the jacket. That's what does it. I'll take off the jacket. So, you know how owls, see? My keys. Okay, when you guys are done stripping me.
What is it? A script right here?
I don't know. See, it's still not doing right. Whoa. Oh, come on.
It's a steel toe boots.
Those are not steel toes, sir. Okay, just give it a moment. Let it stop being cranky. Okay, so we know what owls look like. They got those big eyes. They've got that little beak. They got those big fluffy sides.
Aww.
It's cute, right?
Yeah.
And you got those robots. They got the little beady electronic LED eyes. All those creepy mechanics and extra parts. And some of them have tank treads. Do you see the ones that run around on tanks? Those things are terrible and like, hello. There we go. And they're scary. So look at this. If I have open circles, what side am I using?
That's in first.
Right. And then I use the parentheses for set builder notation, right? For the other ones, if I have a closed dot, what am I going to use? The equal to. And then I'm going to use brackets. Okay? Owls and robots. Owls, they're soft and fluffy. You can't ever touch them. That's why they go to infinity. Right. Yeah. You know what? I'm not even going to.
I mean, mathematics.
Just sit down. Okay, so for the other part, robots, they're hard, calculating, precise machines. It will go up to a point and stop there. Stop it. We're not even going to go there. Okay. So, that's how we know the difference, right? We can cover one side. We can say open circle is greater than or less than is parentheses. Dot is greater than or equal to, less than or equal to, or brackets. Is it a good way to remember? We all got the owls and the robot? What? All right, okay. Just know this is still being recorded. Thank you very much. Driveway pavers are 5 inches by 9 inches. If you have a driveway of 17,685 square inches, how many pavers do you need? Yeah, that's a mouthful.
honest, when I did this, I did 5 times 9, and then I think it's 5 to 17.
You got this one. You got this one, exactly. So we got to think of this as, we know the area of the entire driveway, right? And area is length times width, correct? So if inches are 5 inches times 9 inches, that means your tile space is going to be 40, what are we doing again? Come on. 40 inches squared, right? 45, my bad. Here, let me just make that just, let me just get rid of that and look, put the 5 there, okay? So if it's 45 squared, and we have the giant thing being 17,685 squared, we're going to divide it. And that's going to tell us how many bricks we're going to put in there, right? Because it's going to be the same volume, so to speak, or area. So can 45 go into 1? No. 17? No. 176. Can 45 go into 176? How many times? 3?
Yeah. No.
4? 3? 4? Do we have 5? Do we have 5? Okay, no. Okay, so let's try that 4. 4 times 45. 5 times 4 is? 20. Who said 40? 2 up there. 4 times 4 is 16. Plus 2, 18. Will that fit in to my 170? No.
3.
Okay, so we're going to do it with the 3. So, and 45, put the 5 there, put 1 up here, 3 times 4 is 12, so it's 13, so 135. Okay, let's do our subtraction now. 6 minus 5 gives me a 1, 7 minus 3 gives me 4. We have put 4 there, and those cancel out, so the answer is 41. We bring down the 8. 418. How many times are we going to go into 418? 9? Yeah. Okay. We seem pretty confident about that. I like that. 9 times 5? Yeah, I got to remember that because you guys already got me on that once today. All right, so 9 times 4? 36 plus 4? 40. 405. Ooh. You do the subtraction on that. 8 minus 5 is 3. Carry down the 1, so 13. 135.
8.
How many times? 8? 3?
Sorry.
3? Okay, are we sure?
Yeah, I'm sure. 3. It looks like an 8.
I don't even have to do it because it's right there, and she's right. So if I just brought that over, 3 there. So how many bricks, how many papers do I need for my driveway?
300.
Yep. I'm sorry. Get you on the tutor. His phone went off. But we know how many papers it is. And that's just from long division and testing the area. It's a word question, I know, but just remember when you're this by this, that's the multiplication sign. It means they're going to be multiplied together. When you say is the area or is this much, that's, you go back to your basic formulas. So I'd say before your test, review over perimeter, review over area. Look at those formulas and figure out how to work them around. Because that's going to be your big scary part at the end of the word questions. Speaking of which, I think there's another one. Yep. Number 18. A rectangular room is twice as long as it is wide. Perimeter is 48 meters. Find the length of the room. How would we like to do this?
Formula for perimeter.
Okay. I like the perimeter start, but I like pictures. Can we do pictures? We're going to draw a box. All right? And we know it's twice as long as it is wide, right? So that means that L equals 2W. And we got a W here. Oh, whoops. There we go. Had a problem there. All right, so we're looking at this, and we said perimeter, right? Formula for perimeter. What do we know? What's the formula for perimeter?
The outside dimension
equals 2L plus 2W.
I like that one. P equals 2L plus 2W. W. You're also right. It's just we wanted a nice looking formula. So if we're going to do this, and we've got a number over here, 48 is equal to P, right? You have the 2L plus 2W. My problem is I have two different variables. And I need to solve for one variable if I'm ever going to get this down to something, right? But we have L in terms of W's, right? So we're going to insert that in there. It's going to be 2 times 2W plus 2W. That's a mouthful. Okay. 48. So I'm going to do the distributive property. If it was something like L plus this, or W plus this, then I'd have to distribute the 2 out to the W and to the number as well. But we don't have to worry about that because it's just multiplication. So 2 times 2 is 4W plus 2W equals 48. Move this up a bit because I'm writing small. 48 equals 6W because we put them all together, right? What am I going to do? All right, so if I divide both sides by 6, I'm going to get W is 8. Okay, I like jumped there because I knew it, because 6 times 8 is 48, it's a rhyme. But, am I done?
No.
Not? But I'm done. I got the answer.
Find the length.
Oh, the length.
Oh, yeah.
So how are we going to find the length?
So it's versus
Right, so we're going to go back and we're going to plug the W into that small little equation that we had. So it's going to be L equals 2 times 8. 16 equals L. That is my answer. So always make sure you reread your question when it's a word problem because it may be asking for something different than what you think you're solving for. I made this mistake a lot. Like, a lot. Many years in a row. Alright, we good? No problem. I'm actually ahead by 3 questions right now, which is unheard of usually. Any previous questions anyone wants to go over with me while he's figuring this and writing that down? What's up? You good? Awesome. Nope, good. So we're going on to number 19. The length of rectangular garden is 10 feet longer than it is wide. The perimeter is 192 feet. Find the length of the garden. Okay, so what am I starting with again?
do your little house.
Oh, right. Yeah, let's I'll draw a garden. I'm not going to draw a house. Okay. We'll be here all day, okay? So I draw a box, and we know that the length of the box, we're going to write up here L, is equal 10 feet longer, so that's plus width. See, so I can just pull that formula out of that statement. That means L equals 10 plus W. And you know, this is W because that's the only other side that's there. So the garden's perimeter is 192. So we're doing the whole perimeter again. P equals 2L plus 2W. 192, right? Equals. We've got what L is equal to, so we're going to plug that in. So it's going to be 2 times W plus 10 plus 2W. So we're going to go 2W plus 20 plus 2W equals 192, right? Hello? Where did my... There we go. One 92 equals 4W plus 20. What's the next step? Subtract 20. Okay, cool. I like that. Get rid of those 20s. Subtract 20 from the 190. I just wrote a 20 there. From the 192, you're going to get 172 equals 4W. divide both sides by 4, right? So 1, 7, 2, 4. How many times does 4 go into 1? Doesn't. How many times does 4 go into 17? 4. 4, I like that. Okay, so we're going to have 16 here. Bring the 1 down, bring a 2 down. 12. How many times 4 does go into 12? 3. Okay, cool. 43. Equals W, right? Oh, that's right. That's right. Because I was looking for length. So we're going to take that 43, and we're going to add it with 10 to get the W, and that's going to make length width. Length equals 53. We good? You caught up? Buddy, you okay. You didn't go the wrong way this time? No. Okay. Question 20.
What was the answer?
It was 53. You good? You want to go back for more?
No, I'm good.
So, we're dealing with money. Whenever we see money, and it starts talking about loans and interest and all that, we have a formula for this. Does anybody know the formula?
IPRT.
IPRT. I equals principal times rate times time. But it's giving you all your things. You just got to plug them in there. Okay, so let's see this. Frederick needs to borrow $3,000 for a down payment on his new car. So he's borrowing that much, right? Is that his principal or is that his interest?
Principal?
Principal. Okay, we'll go with principal. I like that. It's not too hard of a guess because we know exactly what time's going to be and we know the rate's got to be 1%. So these are the only two that we could get wrong. So 50-50 shot, right? $3,000, so the down payment. His uncle decided to loan him the money at 3.7%. Ouch. All right, so that's going to be my rate. So, right. And how are we going to write that since it's a percent?
0.037.
0.037. I like that. All right. Frederick doesn't want to pay more than $333 in interest. I wouldn't want to pay any interest. How many years does it take Frederick to pay back the loan? So, we do not know what time is. But we do know that he doesn't want to go over $333, right?
Right.
So, I've got 3 things set. I've got 1 that I don't. Where do I start?
Good question.
Multiply. I like that. I heard multiply. So if I multiply 3,000 by 0.37, well, I don't think I'm going to like it. It's not going to be fun. Times 3,7, so 0, 0, 0. Those are all times zeros. Then 3 times 7 is going to be 21, right? And then we put a 0 there for the space holder, right? And then I go 1, 2, 3. So 1, 2, 3. 3 times 3 is 9. Going to add this all together real quick. 0, 0, 0. That's going to be a 1. And then 2 and 9 is going to make it an 11. Oh, wait. But I've got 1, 2, 3 decimals, right? So 1, 2, 3. That means 1, 1, 1. It's going to be what's going to be over here. Question what?
My teacher tried to tell me that we were supposed to set that up like proportion, like 324, or we got 327. The 327 I basically divided by 100 because it's a percentage, so out of 100.
If he's trying to make a fraction out of it, if you can do the math decimally, and you can trust yourself to do that, it makes you the number much quicker. Because right now I know that per year, I'm going to be paying $111 of interest, right? And I don't want to pay more than $333, right?
Right.
So that means I'm only going to be paying interest for how many years?
3 years.
3 years. Because all I'm going to do now is because it's 333 equals 111t. I'm going to divide both sides by 111. It's going to cancel out. It looks like Roman numerals all over the place. And that's going to be 3 over 1, which is 3 equals t. So that's going to be the amount of years. You could do it the ratio way, and if that's something that you're better at mathematically, by all means, do it that way. It does make sense to do it that way, but if we're just trying to do the basic math here, multiplication and division of decimals should be easier than doing ratios, because you have places where you could mix up your ratio, or you might multiply the wrong thing or do some division wrong. Here, we're just putting it in the formula and then just moving everything away from t, or from the variable. Okay? Any other questions for this one? I know this is usually a scary one. No? We're good? Okay. So he wants to pay off $3,000 worth of money in 3 years. I hope he does a good job. 21. Restaurant, the bill comes to $50. You decide to leave a 14% tip. How much did you leave for the tip?
Question
Is that proportion?
You could do proportions again, like we said earlier, but also I can do that multiplication by the decimal, and I can get my answer there too.
Okay, let's see that.
Let's see the decimal one? Okay. So we got 50. And I got 14, so I'm just going to put 14 below it right now. I know that the point is right here, but wait, come on. Point's right there, but I'm going to ignore it right now. So 4 times 0 is 0, 4 times 5 is 20, so we're going to put a 0, put a 2 here. Then 1 times 0 is going to be 0. I put a 0 for the placeholder, 0 for that one, and 1 times 5 is 5, right? That means we're going to get 700. We got 2 decimals to move back, right? 1, 2, because we moved over. 1, 2. So that means my tip's going to be $7. How do I know that? Because say I went from $50 to $100, and I'm looking for 14%. So if I just took that in half, it would be 7. So it kind of checked out, and you could even do the math on it and go 7 plus 7 plus 7. You could add it up.
Can be 50 times 40 is over 100.
You could do that, yes. But say I just turned this 50 into 100, then I would be leaving a 14% tip equal to $14. And because I multiplied this by 2 to get that, I divided this by 2, and that would give me the $7. This is like a back way to check my math. Okay?
Or you could just divide 14 by 5.
There you go. See, there's several ways to check your math, but find a stable way that you're good at, whether it's ratios, whether it's decimal math, and work that through. Even fractional math, like she was saying over there with the putting it over 100. It works. It's just I don't like fractions, so I don't do that. All right, are we good?
Yeah.
Anybody got questions on this one? We're actually doing really good on time. You know that, right? It means I'm gonna have a lot of Q&A session for you guys. 22. Tracy paid $160 for an item that was originally priced at $390. What is the percent of the original price that did Tracy pay? Okay.
$160 to decimal multiplied by 190. Or
That's originally.
Multiply.
How about divide 390 from 160?
390 from 160. That would give me the percent in which is left. That does not. You can see. Yep, that's right. Good job. Because we're not looking for the percent it moved down. We're looking for the actual percentage of the original. So what we'll do is we will divide 160 by 390, right? 390 go into 1? No. 16? No. 160? No. Now here's the key point. I'm going to put a decimal there, and I'm going to put a decimal here so I don't get it mixed up from this point. because that's where my number ended, right? So if I now put an imaginary 0 out here, does 390 go into 1600? Yes. How many times?
4.
I like 4 because it's almost 400, right?
Yeah.
So cool, we're going to do that. 390 times 4, 0. 4 times 9 is 36. We're going to put the 6 down, carry the 3. 3 times 4 is 12, plus 3 is 15. That looks pretty close. And we're going to put that little 3 up there. We're going to do our math, right? No, 4, my bad. 4. No attention to the mistake there. All right, so bring it down, 0. Bring the 1 over, that's going to be, what, 4? It's going to be 4,000, right? Because we're going to bring these two imaginary zeros out and bring it down. We could do it by 400, actually. My bad. We're going to just delete this whole thing here. Because that didn't need to exist. So we bring down 1 0. We got 400. We can fit that in one time, right?
Yeah.
Put the 1 up there, put the 3, 90. Get this, it's going to be 10. Right?
Yeah.
Can I put it into 100? No. Can I put it into 1,000?
Yeah.
Yes. Now, hold on. Before I go too crazy in this and keep going on the division, we need to round 2 decimal places, right? So we're at 41% already, right? This was a 0. Next one is going to be the one that's going to tell me whether or not I'm rounding up or down, right? Okay, so how many times is 302? It's going to go in 2, not 3. I can't get it to go in 3?
Nope.
Okay. Hello?
And I think
Yep. Okay, go pick up your son. Oh no. If you want to speak to Adam on your way out, he should be able to get you the code for getting back into this later. We're going to give everyone else that code as well.
And do I still get my paper time?
no, not yet.
Check with them up front. I'm the one doing the math here. I'm not doing the whole running of the system. But if you want to leave a review, we do have those review papers over there on the sign out. Okay, so what did I lose?
Okay, so
Oh,
before you solve this, I have a quick question. I don't know where we're going. I just want to know why we're going to be dividing,
what?
165, 390. Like,
Because I want to figure out how much it is, and at this point, look, I can tell you it's 41%.
yeah. I know, but if we're looking for the percent.
Yes, we're looking for the percent. We're trying to see how much, if this is 100%, we're trying to see how much percent this is of it.
Okay.
And a way of doing that is dividing the smaller number by the larger number. Because that tells you how many times it's going to go in, but it does it in the decimal. And because it's in the decimal, we can easily convert it into a percent. So, yep.
You get that 0 up.
These zeros over here?
No,
Up here?
yeah, down.
Because when I had 100 down here, I couldn't get 360 into 100.
Yeah.
So that one failed, so I had to add another one on top of it. So I had to double add the zeros. Okay? So that told me that that one's going to be 410. It couldn't go in that time, but it'll go in this time. Okay? And because we're doing it by 2, that's what we're saying?
Yeah.
8, 1, 6, 7, so 780. And that's going to be by 2. We do the math on that. 0, borrow the 1, 2, borrow that one. So that's going to be a 9. Yep. 220. Can I get that to go into 220? But we're going to add the 0. It'll go into 2020, right?
Yeah.
Now, this was the last one I needed, right? The 10th. But I need to know if I'm rounding up or rounding down. So at this point, this number, I don't have to know what it is. All I got to know is if it's greater than 5 or if it's less than 4, right? So I've got 2,200 there. Well, when we multiplied it by 4, because we already did that, it was at 15. So that means it's going to be 5 or greater in the 22, right? So that means we will be rounding up. So I immediately know that this is going to be greater than the 5. We're going to turn this into a 3, and then we can say 41.03%, right? Does everyone get how I pulled that out there? I'm hearing some shock and awe right now. Hello. Did I lose people?
I just wanted to know why you would divide 160 by 396. Like, how is the greater number divided by, or the, you know, bigger one over the smaller one? But, like, you know.
Does anyone have a good answer for him? Because right now,
Why not?
I'm
No.
okay, yes, ma'am.
You're looking for the
How about after the review session, we'll go over that more in depth as to why that works. But yes, I'll get on to the next question. Number 23, right? Find the x-intercepts of the line as an ordered pair. So, there's the x-intercept and the y-intercept. How do I know the difference between x-intercepts and y-intercepts?
X is horizontal, Y is vertical.
So, when I'm looking for the x-intercept, I want y to be equal to 0. When I'm looking for the y-intercept, I want x to be equal to 0. So whichever one that I'm reading, I want the other one to be 0, right? So in this case, I'm looking for x. I want y to be 0. So we're going to take that, I'm going to plug it in up there. So negative 2x, put a 0 in where that y was, so suddenly the 3 is multiplied by 0, it doesn't exist. That whole section just got deleted, basically. Equals 18. What do I do?
You lost me.
You lost? I lost you? I lost? How? Okay. So don't shake your head at sketch. X is when y equals 0, right? So I put in the 0 for that y up there.
Okay.
On the 3y, so when it's negative 2x plus 3y, I put a 0 in with the y. When I multiply that 0 by the 3, it's gone. So, okay. You're good? You good?
Yep.
So we end up with this one. We divided both by negative 2. This cancels out. We have x equals negative 9. Now I'm looking at this and going, okay, that's the answer, but they want it as an ordered pair. Ordered pair is requiring us to have one x value and one y value. So we know our x value is negative 9. What's our y value?
0.
That's right. We already said it was 0. So we're going to put that 0 in there real quick. And we're going to say that's our ordered pair. Okay?
So pretty much the x-intercept is going to be an equation.
Yes. Well, because we take this equation that we have, we know that y is equal to 0 when we're looking at the x-intercept.
If we're looking for y, it's
X is equal to 0. Yep. It's whichever variable you see, the other one is 0 at that point. Because that's where it crosses those strict axis lines. And then from there you just plug in that number to solve it, and you solve for your variable. And that'll tell you what that number is for that one. All right.
But why would it be negative 9 when 9 times over? Yeah, my bad.
Negative 2. We're divided by negative 2. All right. Question 24. Find the y-intercept of the line. So what am I setting equal to 0?
X.
X? Cool. So if x equals 0, we can get rid of the 7, right? That leaves us with negative 2y equals negative 42. What am I going to do? By what?
2.
Okay. Negative 2. All right, so it cancels out. Y equals 21?
What's that?
What?
Yeah, 21. 42 divided by
Oh, yeah.
21
Okay.
positive.
2.
21, okay. I'm letting everyone catch up mentally here. So I've got that, but we're going to do ordered pairs again. So which one goes where? So it says 0, 21. Does that sound right, everybody? Yeah. All right, cool. Next one, 25. Find the slope of the line that passes through the points this and this. So we know what slope is, right? That's the formula for slope, or well, the whole equation, but we're just looking for slope. So slope is equal to m, right? Another way to say it is rise over run. This is a nice way of saying it because when you think rise over run, you know that rise is the y values and the run is the x values, right? Mm-hmm. And we're going to say y2 minus y1 equals x2 minus x1. Doesn't matter which way your points are, as long as you keep all the signs the same, it will show you the same slope either way. So I can pick this to be y or x2 and y2, and this to be x1 and y1. But if I mix up which ones are where, it's going to get wrong real quick. Okay. So I'm going to write over top of them. This is going to be my x1, and this is going to be my y1. This is going to be my x2, and this is going to be my y2. All right. Now let's try and plug those into this equation. So we're going to do y2's first, right? So negative 1 minus a negative 14. Wait, no. Oops. I'm doing that. Doing that right? Yeah, I'm doing that right. So, because I got a negative and a minus, I'm going to do a plus here. Alright? Next part, x2. What's my x2? 13? 13 minus 9. Okay. So, we're going to write it out better. Negative 1 plus 14 over 13 minus 9. Let's do those numbers. So we're going to take 1 away from 14 and get 13, right? Over 13 minus 9. Who's that quick math? 13? 4? We sure it's 4? Are you sure? Okay. 4 and 13. Can I make this any simpler? I cannot because we have a prime number. We already have a prime number there. There's no other way I can divide it. So we know that that's going to be the slope is 13 over 4. So it's going to go 13 numbers up and 4 numbers over. Okay? Any questions?
So would you
Start with y2, like,
that's the thing. It's always going to be y2 minus y1 and x2 minus x1. But you can choose it. I could have done this as x2, y2, and x1, y1. I just got to make sure that they stay together. That x1 and y1 are the same ordered pair, and x2, y2 are the same ordered pair. That way they don't clash with each other. And if I do that, I'll end up with some skewed numbers because they're going to be the wrong coordinates.
So m equals slope, right?
Yes. Because m equals slope. M also equals rise over run, and that's how you remember it's y2 minus y1 over x2 minus x1. That's a formula you guys are really going to want to remember. Your whole next class after this, the 1033, they love that. They do that all the time. They think it's like foreign into you. That's how much they want you to do it. I don't like it either, but what they do. So we're going to find the slope of a line.
And slope is always in a fraction, is it not?
It could be a whole number if it's like a perfect fraction, like over a 1. But usually it is a fraction. But don't call it a fraction, or else you're scaring everyone else here. Remember? We don't call things fractions here. So, I look at this slope of the line, and I do that whole thing, rise over run, right? I'm going to look at 2 points that are actually like on a dot. So, this point here is on a dot. Go away, you little. And this point over here is a dot, right? So I could do this as this is being, what is it, 0, 1, and I could do, 5 and negative 1. And I could do the whole y2 minus y1 over x2 minus x1 to do the math of it, or I could count them. So watch this. If I'm moving over 5, right? So I ran 5 this way, correct? So on my division line, I ran positive 5 units that way. How many units did I rise during that time? -2 actually. I went down to, right?
Which one you doing?
I'm doing this point to that point. I got to read from right to left, right? So if I'm reading from right to left, I ran 5 units this way, and I went 2 down, okay? So my rise, because I can't say I went 2 down, I'm going to say -2, because I rose -2, right? -2 over 5, does that sound like a good fraction? No? You don't like it? Why don't you like it?
Yeah, why not?
What? I'll do the math in a moment. I'm just saying, like, here's a way to look at it. Like, okay, so if I go this, make this x1 and make this y1, right? x2, y2. So then I'll do the y2 minus y1 over x2 minus x1, right? So my y2 is -1 minus +1, right? And then I've got my x2 being 5 minus my x1, which is 0, right? That's my point, right?
No, let's check like the 0, 1.
Which one?
Like the dot sign,
Yeah.
4 and 1.
Yeah, this one up here?
So it starts from the bottom, so we're going.
No. When I was here, I went 2 down, then I went 1, 2, 3, 4, 5 over. Okay? So I moved 5 over positively, because this is positive, that's negative. This is positive, and this is negative. So I moved 2 in the negative, and then I moved positive 5. But when I do the math of it, even with the point, I end up with 1 minus 1, which is -1 minus 1, so it's -2, right? And then 5 minus 0 is 5. So I've got,
It's just
right.
that way is easier.
I think that way is
Yeah,
easier.
yeah, you're right.
Maybe I'm wrong. Maybe you want to do the math just to make sure.
I don't want to do
But that's the whole point of this class. You signed up for the wrong class. This is the point of your math.
I didn't have choice. I did.
Don't worry, you'll love it by the end of it.
Yeah, not with the pictures.
Okay. Well, I can't help that. But Sam Marugan, you can always write him a letter. He loves math. You don't know about Sam Marugan? He's your head mathematics instructor for like everyone here. What? Yeah. So if you write him a letter about something with your teacher, like I would try and talk to your teacher first. But if you have issues over time with your teacher, I would just send a letter to Mr. Marugan because he would be the person to go to on that. Because he runs all the other math systems. I can't. I have no power over that. I'm sorry, guys. I don't have power.
With him now. We have
I-
a midterm review. Now we're going on with him.
I am aware of this. I have no power to change this. I'm trying to tell you the way that you guys can change it because you are students and you have that power. If you work together. Mr. Sam Marugan, you can search him up on your Atlas email and you'll find his email contact for you. Sam Marugan. M-A-R-G-U-A-N? Marugan? Like, somebody in this class. I'm sure you can find some student here that's been running class that spells last name. Alright, so let's keep going because we've only got 4 more questions. And then we got like a half hour that can go over any Q&A sessions. Determine the slope of a line represented by the equation. What was slope? Does anybody remember what we said slope? Well, there's that. What was the variable? M, right? So if I did this y equals mx plus b, and then I wrote y equals -1/5 x minus 3.
The slope is -1 over 5.
What color is the red barn, everybody?
Red.
Purple? I like you. You figured out there's people that are colorblind. Good job. -1/5 is going to be your answer. They're just asking you to find the slope, and the slope is already given to you in your answer. You just have to remember this formula. And sometimes it'll be y with some number in front of it plus x with some number equals a number, equals something else altogether. When you see those, just turn it into this format. move the x over to that side. Move all the numbers over that side. Make y be by itself. When you do that, you'll always have your slope right there. It just falls into place that way. Okay? So if it looks really messed up, just learn how to turn it into y equal to x plus b, and then there's your slope.
So here's the thing about the slope.
Yeah.
Is negative 1/5 the same as negative 1 over 5?
Yep. I'm literally moving 1 down and moving 5 over.
But that would be positive.
Yeah, I moved 5 over, positively.
The negative is.
But the negative was the top part.
Okay. Yeah, but in the slope written in the paper, it's expressed as negative. Both of them are negative. You know what I'm saying?
Where? Oh,
Because you wrote that negative 1 over positive 5.
right, because this can only work with one of the numbers. It can't work with both. Because if both were negative, they just become positive.
Right. Oh, yeah.
So one of them's got to be negative there, okay?
Can't be positive.
Right. Okay, but if I did it, let's do it your way. If I move 5 negative, and then I'd have to move 1 positive, right? It's the same line.
Oh, wow. Okay, yeah.
Cool. They're mirrors.
It doesn't matter.
It doesn't matter which one's negative. But if you treat the bottom one as positive, because you're running forward in time, it'll make it a little bit easier for your brain. Alright? But like, if I went -5, I would have to go +1, because only one of these is negative, right?
Right.
So I just went up. And if I went down and went 5 forward, it's the same line.
So those just go up into that.
Yep.
But it's not the same as positive 1 over negative 5, right?
+1 over -5? You're saying +1 over -5. So that means that I go up 1, and then I go 1, 2, 3, 4. Okay, let me do this somewhere else. This is a bad idea.
Well, I mean, I kind of see it.
Yeah, but like, he's not sure yet. He's getting there. He's just not sure. So, yeah, go up, go away. So if I went, you said 1 positive. Come on, 1 positive, and then 1, 2, 3, 4, 5. If I went 1 negative, come on, and then went 1, 2, 3, 4, 5 positive. That's the same line. Okay.
So the slope is the same.
The slope will be the same no matter which part you make negative or positive. It's just weird math of fractions. Because whenever you're doing the whole multiplication, you know it's going to be a negative line versus a positive line.
Right.
Number 28. Determine the slope of the line represented by the equation. This is what I was talking about. This doesn't look nice. We're going to turn it into a pretty y equal to x plus b, right? That's the first thing we're going to do. Anybody else agree with them or disagree with them? Okay. We're going to get you several pins for hello, my name is. You can write whatever names you want on them. We're just personality. Alright, so minus 1x from both sides. We can make -9y equals negative 1x minus 11. What's my next step? You're sitting here. What am I going to do?
Add 9y.
Add what? What? Where? Why are we adding?
Because we're actually y.
Yeah,
So
so
you want to add 9.
can somebody help him?
Oh, I'm sorry, divide 9.
So we're going to divide both sides by -9 because I want to get -9 away from the y, right? So we do that. That gives us y equals -1x minus 11 all over -9, right? I'm going to break this into 2 fractions now. Ready? We're going to do -1 over -9x minus, whatever, plus negative, come on. not a new board, it's a new computer crane, because at this point it's just being temperamental. I'm just hoping every time it ends, it comes back up. It's actually opening the title for the recording. I really hope so, but I can't. Yeah, I see that. You wonder how I'm good at writing these. So I'm looking at these. These are going to make everybody positive, right? Because they're all negatives. It's negative over negative, negative over negative. We're going to just turn them all positive. So y equals 1 over 9x plus 11 over 9y. And those are, one of those is a prime number, so I can't really do anything with it, right? That's my slope, and I go, or sorry, that's my line. I go y equals mx plus b. What's my question? Slope. Somebody tell me what my slope is. 1 over 9, because m equals your slope. And you're going to write it as m equals 1 over 9. That way your teacher knows that you understand what they're talking about. Okay? Everyone good with that one?
Yes.
Kind of. What's wrong?
How did you get from 9? I don't want to hold everyone else. So I'll ask you after.
Okay. Do you guys want to do the question, or do you want?
Okay. How did you get from negative y, negative 9y equals negative 1x plus 11, and divided them both by 9? How did you get? How did they convert to a positive number?
Because we divided by a negative number.
Oh right, yeah. Okay.
So because it was a negative over a negative, it just became positive. Because it would be both going backwards, down and down and backwards. So it's going to be going up and frontwards. So it's from the positive line.
Right. Okay. Cool. Thank you.
We good?
Yeah, I got it.
What was the final answer?
The final answer was m equals 1 over 9, right? Okay, cool. Somewhat know what I'm saying. All right, so which of these graphs is represented by the following tables? We're going to do this by trial and error. So my favorite part with this is I'm going to start with the intercepts, because the intercepts are the easier part, and we're going to be able to eliminate half of them. So intercepts are when one of the lines equals 0. So these two right here, okay? They gave me both of them. That's great. So if x is 0, y is negative 2, right? So at the line that x is 0, which is this giant line here, I need to find a y that's at negative 2, right? So looking at this, these two are positive, right? So they just got completely gotten rid of because they're positive. Now this one has still got that, and this one's got that. So let me look at the other one. If y is 0, then x is 1, right? Well, that one's at 1. This one is not, right? See, that's at negative 1? So that's not a good one. That's my answer. And I can confirm it with the other one. If I go to x equals 2, y equals? If x equals 2, y equals 2. So that's also on the point. If I go to negative 2, well, it's half 5, so we're going to guess this at that one. That one technically is a dud because we can't see that. But we can look at the other one and go, well, for negative 1, we're at negative 1, 2, 3, 4. So that all checks out. So this is going to be our right answer right here. It's number 2. Okay. So it was the last one, right?
No, well, on my paper, I have everything else, but don't have it.
Okay. Guess what, everybody? We are getting to question 30. Which equation is represented by the graph? Now, first thing we're going to look at is, what part of the line am I going to look at to determine this first? Slope? I'm actually going to say, let's start with the y-intercept, which is b, right? So So all these numbers out here are b. And b is when x is equal to 0. Where is my b? -2. Right, 0, -2. But we know that it's at -2, right? And that's what these numbers should equal, right? So suddenly, I'm going to change my color again so they understand this. That's not right, because that's a +2, right? He's not right, because he's a +2. Now, what's one other thing you can tell me about my line? Just by looking at it. Is it positive or is it negative? Positive slope, right? So that means I shouldn't have a negative in front of my slope, right? And I have horrible handwriting on these things. But if I have that, and these two are no longer answers, uh-oh, that one's negative. Our answer is the first one. Yes? I looked at the line and I said the line's going up as it goes across. I could also have done the math behind it and said, well, if I'm going over 1, 2, 3, I'm going up 1, 2, and that gives me a 2/3 as my slope. Right, right. So say it was going downwards like that, I would have gone, okay, I moved over 1, 2, 3, and I went 2 down, and that would be a -2/3. And that would be a negative slope. Right? We good with these? All right, I'm going to end the recording, and then we can have Q&A session.